All right, so a couple of announcement type things before we begin. So the first one, the other day, Johannes had asked me about the Bluetooth, and I mentioned that I was recording classes from now on, and so I just want to show you what they are and how you can access them. If you log into Moodle, you will see something like this. If you don't know how to log into Moodle, there are instructions in my syllabus. The very first document is new. It says how to access class videos. It's a Word document. If you open that Word document, it says this. Pretty much just tells you to go to this page right here. So I'm going to go to that page. If you put your mouse over the link, it says hit Control-click to follow it. So we're going to start on page 13. Just a couple of announcements before we begin on page 13. Okay, and what you just heard coming through the speakers was what I said to start Tuesday's class. Let me fast forward a little bit to something where I'm writing. Let's see. Okay, maybe something in here. Julian, is there any place outside of a math class for Julian? Okay, 10 to 15. Very good. Come on, Julian. Okay, so this is what I was trying to describe. This video exists. Just go to the website and it will stream for you. You can see it's the video along with the audio synced up together like a movie. And the nice thing about this, the nice thing for me anyway, is that I am not going to go to Moodle and post one of these every day because the format for the URL is always going to be this. So you got this gobbledygook here about the media stuff. You got Winokur. The only thing that's going to change is what? The date. This was the video from February the 7th. If you want the video from today, it's February 9th. Change the 7 to a 9. You can download this from any, you don't need to be on campus. This is just a website. Go to it and the video should start opening up in Windows Media Player or something. I thought you can't stream it online. It is streaming, is what we were watching. But you could also see I could fast forward through it as well. Any questions about this? This is a resource that might be useful, right? Yes. Imagine if you missed a class, check it out. It's not a substitute for being here, but it's as good as we can do. If something in class happens today and you're a little bit confused and you want to see it again, just watch it again. And you don't need to watch the whole thing. Just watch the part that you're interested in, right? Okay. So last thing I'll say about the videos. Even if you don't want to take a look at the videos in the near future, at least log into Moodle, open this thing up, and make sure that you have access to the video. Make sure that you can at least play it. Because if it's a resource you're interested in, and you decide that the first time you're going to see, if you're going to look at this video first the day before the test when you're studying, and it turns out there's some technical issues and you can't access it, well, it's kind of too late at that point. So if there are technical issues, let's find out about them soon. And then you'll have this resource if you need it the day before the test. Fair? Okay. All right. Again, we are on page 17. We'll take a look at the calendar. Today is the 9th. You can see that I've highlighted the next 4 classes today and the next 3. And you'll see that actually all of these things have something to do with voting. So voting is going to be our next major theme. The first 4 classes I called numerical literacy. These next 4 classes is all about voting. We might be wondering why voting is appearing in a math class. It seems more appropriate for like a sociology, political science type thing. We're going to talk about some of the politics involved here, but there's actually quite a bit of math happening, or could be happening, in terms of voting. So that's what we're going to get into in the next 4 classes. And at the end of that block of 4, we have our review day, and then we have our first test. Still kind of far away, but it's coming. February the 28th is, what day is that? That must be a Tuesday, right? That's a Tuesday? This is not a, okay. So we're on the 9th, that's a Thursday. Then we have next week, and then we have the following week, and then we have the Tuesday after that. So basically, a little less than 3 weeks from now is our test, okay? Any questions on the calendar? Okay, so on page 17, we're going to go up here to number 1. And we need a reader. Can we start with Wadada? Oh, you don't have it ready. We'll start with Becca, number 1. Let's start. Okay, so I pulled up the page. It's there's some text up above, but this picture is all I'm interested in. So these folks were asked where they would like to go on vacation, and you can see how many of them said Hawaii, how many said Florida, how many said the South Pole. Okay, so where are they going? If they all have to go to the same place, South Pole has won this election, right? Do you think that the South Pole represents the will of the people? No. You've got 4 people who are going to be quite happy. They're dressed warmly and they've got their skis on. And you've got 6 people who clearly, like, there's some stuff in common between Hawaii and Florida, right? These folks want to go someplace warm. They got their sunglasses, got their bathing suits, and 6 out of 10 people are going to be unhappy with the results of this election. And I know it's a silly little example, but it illustrates the kind of thing that can go wrong when you just vote for your favorite thing. The will of the people, I don't think, is represented by going to the South Pole, but this is where they're going. All right, let's take a look at number 2. Maggie. Thank you. Wadada, number 3. Okay, go ahead. So in your favorite choice first, then your second favorite, and then your least favorite. Everybody have their vote? Okay. So first I'm going to tell you what the right answer is. It's vanilla. Just raise your hand if you got it right. Vanilla, then strawberry, then chocolate. Who got it right? Nobody wants to pass this course? Okay. So let's go to number 4, and we go to Zach. Can you read that sentence one more time? Go ahead. Okay, so we're just going to count first place votes. Raise your hand if your first place vote was vanilla. Counting myself. 1, 2, 3, 4. Raise your hand if your first place vote was chocolate. 1, 2, 3, 4, 5, 6, 7, 8, 9. Raise your hand if your first place vote was strawberry. 1, 2, 3, 4, 5, 6, 7, 8. This is quite interesting. This was close. I've run this election a few times in the last few semesters. Strawberry has always been last and by a wide margin, but it was neck and neck with chocolate. It's quite interesting. Who was our winner? Chocolate. Chocolate is the winner. Okay, what we just conducted was called a plurality election, where we only look at first place votes. In fact, it was kind of silly to rank second and third, right? Nobody's second or third place opinion mattered in the election we just counted. You're either first or nothing. Okay, let's go to number 5, Henry. Keep going. Okay, so more than half of the first place votes is called a majority. So the first thing you need to do is count what? Yeah, we need the total. In order to know how many is more than half, you need the total. Okay, so let's find the total. Everyone agree with Johannes? 21 is the total. So we need more than half. So a majority is, yeah. So a majority, how much is more than half of 21? Yeah, half of that would be 10 and a half. We need to go more than that, 11. Did a flavor receive a majority? No, which is okay. It's possible that a flavor could have gotten the majority, but even if it doesn't, there's still a flavor that has more than anyone else. So the answer in this case was nope. I think part B we've already answered. How many votes are required to have a majority in this class? It was 11. Remember, majority means more than half. We'll go to Holly for C.
How many votes are required to have a majority in the class of 49?
Okay. Again, majority means more than half. What's half of 49? 24 and a half. More than that is 25. In a class with 50, how much is half? Yeah, how much is half of 50? It's 25. Half is not enough. Majority means more than half. So if you're at 25, you need to bump up to 26, okay? Majority means more than half. Okay, let's go to 6, and we're up to Jocelyn. Yes, please.
Voting method, all the candidates have a preference ballot. So take a preference ballot. Take a preference ballot.
Okay, so on the next page, we're going to tally everybody's preferences using this thing called a preference schedule. This is a list of all the possible ways to vote for vanilla, chocolate, and strawberry in any order. Circle the one that was you. You picked one of those things because that's a list of all the ways to do it. And now we're just going to get a tally. Is it guaranteed that somebody voted for every one of these? No, there could be some up here that had 0 votes for it. All right, if you were the top left, raise your hand nice and high. 1, 2, 3, 4. Middle and the top. 1, 2, 3, 4. Top right. 1, 2, 3. Bottom left. 1, 2, 3, 4. 5. Thank you. Bottom middle. 1, 2, 3. Bottom right. Just poor. Okay, did we get, is that 21? It should be 21. Is that 20? We said 21 before, right? Okay, so we made a mistake someplace. Not that big a deal to me to catch it, but it should have been 21, right? They got to have the same number for both. Okay, so this thing right here, a single one of these is a preference ballot, one ballot. Like you go to the polls and you fill out a ballot. The list of all of them is called the preference schedule. Just like in your schedule of classes, you're listing all the classes. All right, so we go to 11. The nice thing about the preference schedule is that it is a compact way to record everybody's desires. This little thing encapsulates everything about this class's desires for those ice creams. Okay, let's go to 11 for Blake. Okay, so you saw the 6 possibilities for the 3 choices of ice cream, right? So if I add another choice of ice cream, somebody name a ice cream flavor.
Blueberry.
Blueberry. So if blueberry is another choice, just take a look at the people that voted, in the first option here. So blueberry maybe is their first choice. That's like one ballot, right? With blueberry first and then chocolate, strawberry, vanilla. Or Blueberry could have been squeezed in between first and second, or it could have been between second and third. Anything else for Blueberry? It could have been dead last, right? How many possibilities did that one ballot like expand into? That's an extra 4, right? One ballot became 4. Well, this ballot right here, how many would it become? It would become 4. So each of these would become 4. So the 6 becomes how many in total? Is 24. The 6 that you had times the 4 places that Blueberry could go. There's now 24 different options for 4 candidates. If we want to bump up to 5 flavors, yeah, okay, so let's see. So first, how many ballots do we currently have with 4 flavors? 24, so that's our starting number. So we're definitely going to take 24 and multiply it by something. Right, you got 24 ballots, and each of them is going to expand, so we got to figure out what they expand to. It's tricky here. Just imagine, yeah, I think we had 1 vote here. How many, like 1 ballot with 4 candidates, if you add a 5th flavor, it could have been 1st, 2nd, 3rd, 4th, or 5th, right? You already had 4 flavors up there. You could squeeze 1 more into how many slots? Into 5 different slots. So each of these ballots becomes 5 new ones. So 24 times 5. So even with 5 candidates, it's already quite big. With 5 candidates, there's 120 different ways that people could vote. And to build our way up to 10, what would you multiply 120 by? Don't jump quite there. We have to go first up to the next. Multiply it by 6, and then that number gets multiplied by 7, and that number gets multiplied by 8, and 9, and 10. There is a quicker way. Thank you for asking. Okay, so first I will do it in the slow way. The slow way is to say that, we could do 120, and then the next one is times how many? Times 6, and then times 7, and then times 8, and then times 9, and finally times, 10. Okay, that's the answer. If you have 10 candidates in an election, there are about 3.5 million different ways for people to vote for them. If we call the candidates A, B, C, D, E, etc., then one way to vote for them would be A, B, C, D, E, F, G, H, I, J. Or A, B, C, D, E, F, G, H, J, I. Or, right? And you'd imagine there's like tons of ways to vote for these folks in different orders. There's this many, about 3.5 million ways. So what's the faster way to do it? Well, here's the faster way. It turns out that the answer to these questions, the answer up here with 3 candidates, chocolate, strawberry, vanilla, was 6, right? Which happens to be 3 times 2 times 1. 6 different possibilities with 3 candidates. 3 times 2 times 1. With 4 candidates, 4 times 3 times 2 times 1. How much is that? That's 24. With 5 candidates, 5 times 4 times 3 times 2 times 1. And it turns out that in math, we don't like writing all this stuff. If we see patterns, we're going to give notation to represent those patterns. And in math, here's the notation. If you see 4 followed by an exclamation point, it either means the author is quite excited about the number 4, or more likely, it means 4 times 3 times 2 times 1. 4 exclamation point, but if you wanted to read it, you'd read this word, 4 factorial, means 4 times 3 times 2 times 1. On your calculators, well, can you maybe write out what this means first by hand and then find it on the calculator? 6 exclamation point, 6 factorial. What does it mean? Starting with what number? 6 times 5 times 4, all the way down to 1. Now on your calculator, you might see a button that says X exclamation point. You might also see a button that says PRB, which stands for probability.
I found that.
I'm gonna have to do that the long way, huh?
It might be in here. There's a lot of buttons to look at. There, it's in yellow. See the X exclamation point?
Oh, yeah.
So if you type in 4 and then second and then this guy, 4 factorial is 24. Okay. How much is 6 factorial? Did we get 720 for this one? So for you, you're going into PRB, which is that button. Now first hit the 6. Then go to PRB there, and then scroll over to this guy. Hit the arrow again. There you go. Enter. Or equals. Equals 720. Hit equals again. You're welcome. Okay. So a couple of folks have found a button that says PRB, which is how you do it on some of the calculators. If you wanted to do it on a graphing calculator, here's how you do it. It's a little bit complicated, so just take a look. No, it's once you know where it is, it's easy. Okay, here we go. On the graphing calculator, you hit 6 because we're doing 6 factorial. Here's where the exclamation point lives on this calculator. You go to math, which is on the top left. We get this big, complicated looking list of menus. In the top right, it says PRB. That's where we want to go. So hit the right arrow a couple of times until you highlight PRB. And then inside of there, you see a lot of choices, including the one you want, which is number 4. So hit the 4. Exclamation point gets copied out here, and hit enter, and we should get 720. Is there anybody who has not been able to find the factorial button on their calculator? You got it?
Yeah, and that's just a simple way of saying it's 6 times 5 times 4 times 3 times 2 times 5.
That's exactly what that is.
All right, awesome.
Okay. Anybody else having trouble? Kelly, you found it? Okay.
So you do 6 and then you the buttons here.
Okay, so this one, PRB. You need to highlight, yes.
Oh.
Yes. Okay, so then if I wanted to find the answer to this one, 10 flavors, 10 factorial ways to rank them. And on the calculator, a lot easier than what we typed before if you can just get your exclamation point up here. Then we should get that 3.5 million number that we saw before. Random question, unrelated to all this. If I asked you how many seconds there were in 6 weeks, do you know how to answer that question? How many seconds in 6 weeks? I'm just going to type some stuff. So what would we do? Okay, so we've got hours. Just tell me what numbers are we? All right, 24 hours in a day. 7 days. 6 weeks. I want seconds in 6 weeks. This is hours. Keep going. Times 60 minutes in an hour. I want seconds in 6 weeks. And then 60 seconds in a minute. Agree? So crunch all these together. Whatever I get is going to be the number of seconds in 6 weeks, right? Weird, isn't it? The number of seconds in 6 weeks is exactly equal to 10 times 9 times 8 times 7 times 6. Just strange. Strange. Okay. All right, undo. Okay, let's go to number 12. Number 12, and we're up to Justin.
Here's our first math example.
candidates for R, E, and G, and the preference schedule is defined.
Okay, so that top row is the first place vote, and then second, and then finally third place votes are the bottom row. So for example, the first column represents the people who think which one is the best candidate, R. And those same people think which one is the second best candidate, D. And those same people think which one is the worst candidate, G. Okay? Those 40% think R, and then D, and then G, just like you guys rank the ice cream. R, D, and G are chosen to represent Republican, Democrat, and Green, just to give context, but it could be anything. Okay, so first question, who is the plurality candidate? So I think it was either Zach or Henry. I think it was Zach that read to us that the plurality candidate is the one who gets more than anybody else in terms of first place votes. So we've got R, we've got D, we've got G. And the fact that we're looking first place votes only, so only the first row matters. How many votes did R get total? 45. 45 first place votes. And that's all that we're looking for when we see this phrase, plurality. How many votes did D get? It was 40. And G, 15. As a quick check, what do you get when you add them up? 100%. Gotta be here. Okay, who was the plurality candidate, the one with more first place votes than anybody else? R. So this one here, R. And if we conduct the election doing the standard thing we do with elections, R just won. Is he also a majority candidate? Majority means more than half the votes. Did R get more than half the votes? No. Okay, you can have more than anybody else without having more than half. Let's go to 15. We're going to do something different. This has been standard. This is how we elect people. You just vote for your top choice, and whoever gets the most wins. That's it. Let's go to Hillary for 15. Okay, so let's just compare D and R. That's all. So first thing I'm going to do is erase that top row because that's not relevant anymore. I'm just looking at D and R. The first column, between D and R, who did these folks prefer? R. I preferred R. So I'm just going to highlight that R gets those 40 votes. Between D and R only, in the next column, who gets those votes? R is preferred to D. The next column, between D and R, who gets those? D. D is above, so D gets those. I'm going to change color, so D can be there. Between D and R, who gets the next column? D is above. This is where people get lost. Who do these folks like the best? They like G, but that's not what we're after right now. We are currently comparing in a head-to-head D and R. G is out of the picture. I know that these folks really like G, but they do have a preference between D and R, even if we have to go look a little bit harder to find it. So this next column, if they only have to pick between D and R, who are they picking? They're picking D. And you can tell because D is above R. Ignore everybody else. That's another green because D is the winner. In the last column between D and R, who do they prefer? They prefer R. We're going back to yellow for that one. So we can add, we can add them all up. So how many does R get? So R had 47, and D had all the greens, 53. Everybody see it? As a quick and important check, what do you get when you add 47 and 53? 100. You need to get the total every time. It's really, really tempting to ignore the people who thought G was the best, but you don't ignore them. Every single vote counts. Every voter has a preference between D and R. You just have to find it. Okay, next part. Head-to-head between D and G. Can you guys, in your groups, talk to your neighbors and give me a total for D versus G? Okay, so let's come back together for this first column. Between D and G, who do these first column people prefer? They prefer D, right? They like R the best, but if they have to pick D or G, they're picking D. That's what their preference says. So let's make D there. What about the next column? Between D and G only? G. All right, I'm going to change colors for G. There. The next two columns, who wins those? D, definitely, because D is their top choice. The next two columns, G is their top choice. So we add up the numbers just like before. And I've got G has a certain amount and D has a certain amount. How much does G have? Is that 20? And then D, 80. And it works out again, right? It's got to add up to the same total you had in the beginning. Are there questions on this head-to-head? Okay, so let's think about what happened here. Who won the election just doing the standard first place votes plurality? R won. They won. They had more than anybody else that's here in purple. But in a head-to-head competition, who did people prefer between R and D? D. Between G and D? D. G is preferred, sorry, D is preferred head-to-head against every other candidate, right? If everybody has to pick between D and somebody else, they're going to pick D. D is going to win this if we just look head-to-head. It beats everybody. But if we just go first place, which is what we often do here, R is the winner. And I'm not making a judgment here. I'm not saying anything about Republicans or Democrats. I'm just talking about the way in which we count the votes. And it seems like there is something inherently unfair going on with this example. And it reminds me of the South Pole, Hawaii, Florida thing. Is the will of the people represented by just looking at first place votes? Well, that kind of seems to ignore a lot of important information. We each had a preference between vanilla, strawberry, chocolate, second and third place. But we ignore it if we only look at first place. Justin.
So, yeah, something like this could be used to make lectures and candidates of like, well, like now we have somebody running things like this to get prediction as to who is wanting to use the category, and if this guy got kicked off, if one guy comes out of the race, it's easy to say, okay, well then it's just these guys, then.
Yeah, and this is certainly relevant with all the primaries happening leading into the presidential election later this year.
If they don't do anything like this, oh my God, we could write a letter at the time.
We should, because there's some issues here. And I think I'm interpreting what Justin had said. If instead of like having just like put your first place choice, if you are voting in the Republican primary, put your first place choice. If instead we said rank all of these different Republican nominees, is that the right word? Or maybe it's only the winner gets to be called nominee. Rank all the Republican candidates, and we did something like this, then we could look at more than just the first place information. That's all that we're getting when we say vote for your favorite. But there could be relevant information here that says, hey, maybe counting favorites isn't appropriate. Maybe it gives you not an outcome that represents the will of the people. Okay, let's go to, we're going to skip down to 17, and I think we're up to Ashley. Okay, so when I say an election method, I'm talking about how we count the votes. On the one hand, we could count the first place votes. That's what we normally do. On the other hand, we could do head-to-heads and maybe try to find a winner by looking at head-to-heads. Two different ways to try to find a winner. To decide if one of those winner finding methods is fair, we have these things called the fairness criteria. So these things aren't about any specific election, but rather about how we try to find the winner. Let's go to Doug for the first one. Okay, does that seem reasonable? Remember, majority means more than anybody or more than half. Majority means more than half, right? If somebody has more than half of the first place votes, do you think they should win? Is that reasonable that they should win? Yeah, they are preferred, right? They are the top choice. For more than half of the people voting, yeah, they should win, right? Okay, so that seems reasonable. Let's try the next one, the Condorcet criterion. Zach? Okay, so I'm gonna stress one word right here, each. If one candidate is preferred in a head-to-head over each of the other candidates, if one candidate is preferred to everybody else, then they should win. Does that make sense? If in a head-to-head we prefer vanilla over any other flavor, then vanilla is our favorite. Vanilla should win. Take a look at this example that we just talked about, R, D, and G. If we looked at first place votes only, who was the winner? R. R has won this election. But in a head-to-head, was there somebody who was preferred to everybody? Who was it? D. D was preferred to everybody. According to that criterion that we just read, the plurality method, the first place voting method, is not fair. Here's an example that illustrates a violation of that fairness criterion. You counted first place votes, R was the clear winner, but that doesn't seem right because D is preferred head-to-head to everybody. So again, it said if a candidate is preferred by the voters over each of the other candidates in a head-to-head, then they should win. And if they didn't win, it wasn't fair. Lots of vocabulary. Let's try to, let's see, let's go to this R example, and I think we're up to Johannes. R example.
For example, with R, D, illustrates per se.
Okay, there's lots of stuff happening in that sentence. It is supposed to be murky to you right now. The plurality method, where you count first place votes only, violates this Condorcet criterion. Meaning you might have somebody who's preferred head-to-head, but they didn't win when you count